My dear viewers and listeners, today I am going to start a new lesson on measurement of true length with micrometer screw gauge. I have chosen this topic to give you the concept of mechanical scale zero error in micrometer screw gauge. This topic is related to any physics curriculum up to GCE A-Level. My syllabi references are IGCSE, GCSE, GCE O and A-Level. It is taken from chapter 1 measurement. Please note that you can request a physics video on a topic of your need in your comments section. Look at the micrometer screw gauge diagram. You can see an object between anvil and spindle. Anvil is fixed with its frame, whereas spindle can be moved forward or backward when thimble is rotated clockwise or anti-clockwise respectively. A ratchet is also shown on the extreme right of this instrument, which is used to apply proper pressure onto the object to hold between anvil and spindle. Horizontal millimeter scale is engraved on the sleeve representing main scale reading MSR. 50 vertical vernier divisions are also visible on the thimble. Horizontal datum line is shown in red on the sleeve, which is used to find matching vernier division on the thimble. Mechanical scale structure. Micrometer is a metallic instrument. It has two basic parts. Part 1 is fixed and millimeter scale is engraved. Part 2 is movable and 50 vernier divisions are engraved as shown in the diagram. What is mechanical scale error? Micrometer is a mechanical instrument. When it is fully closed, then both zero marks may not coincide with each other at the datum line because of possible mechanical fault. As a result, the measured value is not accurate. This fault is called zero error. This zero error has to be rectified for accuracy. Condition of no mechanical error. Scale graduations of both parts, fixed and movable, are starting with zero mark. Close this micrometer screw gauge with no object between its jaws, anvil and spindle. Both zero marks coincide with each other at the datum line. This shows micrometer has no mechanical scale error or zero error as shown in the diagram. Look at the diagram with no mechanical zero error. Zero of the vernier scale coincides with the zero of the main scale at the datum line as shown in the diagram. It has no mechanical zero error. A simple diagram of a micrometer scale is drawn. Zero of the vernier coincides at the datum line when this micrometer is fully closed with no object between its jaws, anvil and spindle. It has no mechanical zero error. Conclusion. This is a perfect non-zero error instrument. It can be used to measure short length in millimeter. My dear learners, please subscribe this ISRA Science Education to get new updates. How mechanical error happens? It has two reasons. It may fall accidentally on a hard surface. It can be mishandled by the user. Therefore, it may appear as shown in the diagram when it is fully closed. Mechanical scale error. Scale graduations of both parts, fixed and movable, are starting with zero mark. Close this micrometer screw gauge with no object between its jaws, anvil and spindle. Two zero marks do not coincide with each other at the datum line. It is called as zero error. Nature of zero error. We have two types of zero error. First one is positive zero error. Second one is negative zero error. Micrometer diagram with positive zero error. Zero of the vernier on the thimble is below the datum line and it is still in the positive scale region of the main scale. Therefore, zero of the main scale is visible as shown in the diagram with its mark line. It is called as positive zero error. Micrometer simple diagram with positive zero error. Zero of the vertical vernier scale does not coincide with the zero of the main scale, but it remains below the datum line, and some other division is coinciding with it. This shows a positive zero error in micrometer scale. Negative zero error. Zero of the vernier on the thimble is above the datum line. In fact, the zero of the vernier has reached in the region of negative values of main scale. Therefore, zero of the main scale is not visible but overlapped as shown in the diagram with its marked line. Only datum line is visible. It is called as negative zero error. Micrometer simple diagram with negative zero error. Zero of the vertical vernier scale does not coincide with the zero of the main scale, but it moves up the datum line and some other division is coinciding with it. This shows a negative zero error in micrometer screw gauge scale. Only datum line is visible. Positive zero error. My dear learners, for continuation of this lesson for further studies, you will go through the positive zero error calculations of micrometer screw gauge. Please go to video list GCE O-level or FSc. Then you look for the topic positive zero error calculations of micrometer. Thank you for listening my video lesson. Please note that you can request a physics video on a topic of your need in your comments section. My dear learners, please subscribe this ISRA Science Education to get new updates.